Hey everyone, welcome back to our channel. And today we are going to solve today's GFC POTD. And today's problem is delete nodes having a greater or value on right. And yeah, this is a medium problem. So let's start reading the problem statement and understand the institution and approach. And we have given a single linked list. And the problem is asking us to remove all the nodes in the list which have any node on their right whose value is greater. And this is not asking just next node, all the entire right node whose value is greater than the previous one. And this is mentioning here not just immediate right but entire linked list on the right. So let's understand the example first. So here in the first example we have given this linked list and the first element is 12 and the next element 15, which is just immediate right, is greater than 12. So we need to delete 12 from the linked list another time. Next node is 15. We need to check if any node is greater than 15, then 10 is not greater, 11 is not greater, 5, 6, 2, 3 is not greater. Then for 10, we will check 11 greater, yeah. Then we need to delete 10 from the node and we have currently 12, only 15. And the next for 11, we will check if any node is greater than 11, so no. For 5, yeah, 6 is greater, so we will remove 5. So we have just removed 12, 10 and 5 from the linked list. And next time for 6, is any node greater than 6 in the right? No. For 2, yeah, 3 is greater. So we will remove 2 from the linked list. So yeah, 12, 10, 5 and 2 are removed from the linked list. And the remaining ones are 15, 11, 6 and 3. So basically this is what brute force look like, but we have to do this in view of n and without any extra space, so we can't use another linked list. So okay, hope you get the basic intuition of the problem. So let's jump to the understanding part. So we have given this linked list and our head is currently pointing to the first node. This is our head. So first, because linked list is not sorted, so we can't just look 12 next node is greater or not, another next node is greater than or not, because what if 15 is greater, yeah, but 10 is not greater. So if let's say we have example 12, 9 and 13, so 9 is not greater than 12, yeah, but 13 is greater than 12 and 9, so we need to delete both these two. So this will create a problem if we just start traversing. So first we need to reverse this linked list. So after reversing this linked list, we will get here. Let's create a row with another color. So this will be our linked list after reversing. So after reversing, our head is pointing to 3. Then we will need to look that if 2 is less than 3. So yeah, 2 is less than 3. Then we need to delete this node and change the next of this node to that. So this will start pointing to 6. Now we will look if 6 is less than 3, no. Then our pointer will move to 6 here. Then we will check if 5 is less than 6, yeah. Then we need to delete this and this will point to 11. And now we will check if 11 is less than 6, no. Now our pointer comes to 11. Now we will check if 10 is less than 11, so yeah. Then we will delete that node and this will point out to the next node. And now we will check if 15 is less than 11, no. Then pointer next move to 15 and then we will again check if 12 is less than 15, so yeah. So after removing all this, we have left 15, 11, 6 and 3 in our linked list, but guess what, this linked list is still reversed. So we need to reverse it again, and after reversing it again, we will get our desired solution. So first of all, we'll need to reverse this, and this will cost you big of n time complexity. Again, we are traversing this and deleting the smaller nodes. So this will again give you big of n complexity, and finally again reversing this. So this will again give you big of n time complexity. So hope you get the intuition of this problem. So the overall complexity will be big of n, and we will not use any extra space. So the space complexity will be big of 1 in this case. So now we can see the solution. So here we are reversing the linked list. So basically we are creating two pointers, previous and next of type node, and both are of null at the beginning, and just traversing the linked list till head is not null, and then creating assigning next to head arrow next, which is the next node again. So it's better to give great intuition here. So yeah, basically previous is null and next is also null. So head is pointing to 12 first, so we are just changing next to head arrow next. So next will point out to 15 and head is still at 12. Then we are changing head arrow next to previous. So now head arrow next is pointing to 15, but after this will point to null. Okay, and next we will change previous equals to head. So basically previous was at the beginning null. Now previous will point out to the first node, which is 12 in this case. Again we are changing head to next. So now head will move out to this place. Hope you get this. And after this was our first iteration, and in the second iteration again we are just changing the next. So next will point out to the next node, and then head arrow next, which means changing this the next of this second node to the previous one. So this arrow is reversed. So we are reversing the linked list in place. So this will be reversed, and again previous is equals to head. So the previous will move out to the next node, and again we are changing the head to next node. So in the second iteration we just reverse our first node and running this until we change the head to null, and at the last head will point out to null and previous will point out to the last node. So just change the head equals to previous. So yeah, this is how reverse is working. And next, just we discussed earlier, we are just reversing the linked list, then creating our current pointer because we don't want to change the head, and iterating our reversed linked list from current and running till current arrow next is not null, and checking if current arrow data is greater than current arrow next node's data. Then we are just deleting our node, keeping our track of node and changing the next of the previous node. We just see in the approach, and finally deleting this. And if this is not deleting, then we are just moving forward, and after this whatever is left in the linked list, we are just reversing our linked list again using this function, and finally returning our head of the linked list. So hope you guys understand this and I was able to explain this properly. And this is the overall time complexity B of n and space complexity B of 1. So if you like this video, please give a like and also subscribe to this channel for more videos. So thanks for watching. See you in next video.